All right. Good afternoon, everybody. I guess morning if you're West Coast. Let's get some tunes going here. Oddly enough, I think this is actually where this song left off last stream. I don't think I've played anything since. So I've been trying to do a little research into better debugging pipelines. And I think I might have some insight into the issue that we've been having with this sort of stalled pipeline. So, I guess our bot is running. Let's restart it because it probably lost its connection to OBS. So, okay. Bot is running. Now I'm trying to remember where we left off. What is this? Okay, we just changed that stuff around. So right now we have a working pipeline. So if we do a cargo run here. Oh, we do not have a working pipeline. Why do we not have a working pipeline? What did I break? All right, let's look at this. So we're adding Sintel. Oh, because we're going to both RTMP and... Right. Okay, so this is our issue. So if we do this, now we are only going to our auto sync. We run this, this will work, right? There we go. And then we also have, if we can send it to more than one RTMP sync, and this will also work. And now we're going to do some debugging. And first, let's see it working, I guess. All right, let's go to our stream preview here. Here's number 1. And here is number 2. Okay, so both of these outputs work. So our issue seems to be when we mix and match our outputs. So here's what we're going to do. We're going to we don't need yeah, we'll leave that for now. I think that remove worked. So let's just go to one of each, right? Well, I suppose we could just do this, right? And then we'll move back up. Back up. Okay. So if we run this, we can see this window gets popped up here. But if we look closely, we see our pipeline go from null to ready and then ready to paused, but we never play. And I want to say it's pre-roll that happens before there. I'm trying to remember. Let's do, let's just look up GStreamer state change. Okay. So here we go from null to ready, from ready to paused. Okay, so at the pause state, it accepts one buffer and then blocks. So I know that there's a pre-roll, and I'm trying to remember what that means. So we made it to this pause state. Okay, so this is right. So pre-roll happens here.
Yeah, it's super creative.
It is super creative, Rockery Boo. Okay, so I'm glad you're here because I know you have been here to watch me struggle through randomly changing my pipeline and being like, why does this not work? And I still have a lot more research to do, but we may be able to have this all culminate in something that makes sense. So let's generate our graph and let's walk through this. So we have, we're in our pause state. So let's spit out a paused SVG here. Okay. And we're going to refresh this. And now I think I know how we can debug this. So if we look at like this icon here, right? This gives us a lot of information. So over here, we get to see what state it's in. So all of these elements are in the playing state, which means if we're paused, that means some of our elements are not in the playing state, right? And we can also look here to see like which direction things are flowing through the pads, you know, whether we've hit end of stream and some stuff like that. But what I want to do is I want to scroll this way, right? So everything seems to work up until the point where we split our video and audio, right? So we come this way and then we hit this image sync, right? And we get some information here. It's not really telling me a lot, but if we come this way, right, we can see this here. We got this minus pointer equal thing. So we come back over to our legend. It's ready, but paused. Okay. So that element is the one that's paused, which means our entire pipeline pauses. But if we see this direction here, they're still playing. They're still playing. Same thing, the pulse sync is paused. So our RTMP one is playing all the way through. So what's the deal? Well, I guess this is not playing. So there was something that I did learn, and that is that this encoder here has a really big buffer in it. And what happens in this pre-roll stage is the pipeline runs and tries to populate all of the buffers in the elements, including the queues, so that they basically all have data to start with, and then it kicks off the whole process. So what is likely occurring is the buffer in this H.264 encoder is either full or close to full, right? As we're pumping data through this pipeline, there's still room here. However, if we back it all the way up to here, this may have no buffer at all, right? Which means the second the buffer inside of this element is populated, then everything behind here stops producing data. So if I am right, we should be able to, one, look up the debug environment variables for this, and we can validate this. But two, we should be able to stick a queue here. And in front of the audio one too, and potentially solve the problem. Yeah, so I guess we missed it. There should be, right? Oh, we're also... Where's that pad coming from? Our video tee also has an additional pad here, which could also be our problem. Same thing here. Oh, I know what this is. That's another bug. It's still not our issue. No, so those extra pads are because we added this second RTMP feed and then we removed it. So we do have an issue here where we need to make sure that we remove the pad that we had. So let's just run this really quick. We're going to solve one issue at a time. That's the easier one to solve. Okay, so we're still in this pause state. Let's generate that. Let's refresh this. So we still have the same issue. We just fixed this dangling thing there. So do we want to see the logs first, or do we want to just stick a queue there and see whether it works? I need to... close some stuff. We got a lot of tabs here. What's that one? Okay, that's the old one. Yeah, we'll close the rest book. Yeah, we'll do a commit for each fix. So the first one is let's see. There is GStreamer debugging. There's an environment variable. I think it's GST debug or something. Where are you? Okay, yeah, GST debug. And then we can also say buff. It's like GST buff. I know I've seen this where we can debug just the buffer. Let's find it. Is that this one? There we go. Yep. So in theory, we should be able to set that. So we should be able to say, cargo run. We should be able to say GST debug equals this, and this will get us just deeper logging for our buffers. Let's see. That yellow is terrible for stream. So this is allocating here. Okay, so this isn't showing me what I thought it would. I mean, this might be a hint into it. Let's just do a debug 5 and see what happens. Whoa, okay. All right, so here's where we get kind of blocked. Call chain func, type find element with buffer, right? Turned okay. Yep, right here. Okay, see, here's our issue. So we've got Q2, wait free space, Q is full, waiting for free space. Okay, so let's go look where Q2 is in our pipeline. Can we just search for it? Q2. Okay. Which one of you is named Q2? Am I missing the name in here? All right, now I missed it. Let's wait for it again. Okay. So let's kill that there. Audio test source queue is waiting for free space. Okay. So that sounds like it validates our exact issue. So it was audio test queue or test. How quickly I forget. Audio test source queue. Audio test source. There we go. Okay. So this queue is full. So somewhere in all of here is our issue. So we are trying to debug why our pipeline is not flowing. And I was doing some research yesterday. A little bit. I meant to do a lot more. And it does seem like what'll happen in like this pre-roll stage is that we'll try to push data through the pipeline and fill all of the buffers of the elements. And so what'll happen when we split our pipeline up is that we may fill up the buffers on one side and then not fill up the others, which means the buffers in these elements are not full, which means we can't hit our pre-roll and we can't end up playing. So what we need to do is ensure that we have enough buffer so that all of their buffers can be filled. So our issue right now is that we can see this queue right here is full. Which is interesting in the sense that this is not full. Wait, is this where... Is this trying to push into the audio mixer maybe? I'm guessing that's the issue, right? Is that this is trying to push in the mixer, but it's full. Because if we follow this down, we can find this element is paused. So I think that if we put cues here, right? And we do another one on the T for the video before this sync, we should hopefully get data flow. So let's try it. So in our auto output, we are missing some stuff. Let's just video queue, and then we'll make an audio queue. Okay, so wait, no, that's not what I wanted. That's what I wanted. Okay. So let's do this. So we need a video queue, queue. All right. Okay. So that gives us that. Now we need to add our audio queue and our video queue. Okay. So now let's go into our linking function. And this is like these sometimes, like I like this multiple line parameter thing, but then sometimes like you see this weird looking shaped function and you're like, wait, what does this do? Okay. So now we need to add our audio queue to our pipeline. We need to add our video queue to our pipeline. Yeah, let's split this up. Okay. Now, what we really want to do is put this audio element actually represents our T. So let's put the queue on this side of it. So our audio queue will exist between the T that we got passed in and the sync itself. Video queue. Okay. Okay, we're still in a paused state, but it looks like we may have made it further. I don't know. Audio test source queue. Queue is full, waiting for space. Audio resample, pass through. Okay, so it's still the same one. So what did we miss? These are going to be the fun things. We're going to learn a lot about GStreamer internals, I have the feeling, while we're debugging stuff like this. Okay, so it is definitely this point here that we have an issue. So we do have a queue on this side. I wonder if we need, whether it's over here that we need to queue. It's always when we add a separate I mean, it's also possible that the queue isn't large enough. Because it flows into our audio mixer. And this is going to be passed through. There's going to be no buffer in that. That's just trying to hint to upstream what format we want the data in. So I feel like it's got to be this. I mean, we could try this really quick too. So let's do a GST inspect queue. And so we do have this max size bytes, which I suppose we could set to 0, which would just make it like a ridiculously big buffer. Let's see what we can break. We're just going to experiment, and we're going to see what happens. All right, so video, it's the audio one that's the problem though. So audio queue dot set property, and we're gonna set, what was it, max uncapped potential. It was max size bytes, right? Max size. We don't want an infinite queue. And then we were going to set it to 0, and that was going to disable it. And that wants a reference. Okay. So still an issue here. Okay, so that's clearly not what I thought it was. All right, let's look at this again. So it's definitely the audio test source queue. I want to try something really quick too. So inside of our mixer, we have, oh, did we remove that? Background enabled. Let's remove this and see whether that fixes our issue. Okay, so it has nothing to do with that, because now we can see we just saw it. I know that I just saw it here. We had one of the queues that were full. Where did you go? There we go. Okay, so here we've got GSTQ2 wait free space. This doesn't tell us the name of our queue. Did we not name that one? No, we did. I was really hopeful this was going to fix it. This could be one of those streams where we just spend the whole stream debugging GStreamer. And we're all going to be better for it, or not. All right. Let's pull up your clip, Rockerboo. Let's see what we can break. We're just going to experiment. And we're going to see what happens. Let's see what we can break. Okay. So I know... Maybe I'm just picturing the flow of this wrong. But our issue is... I want to know what queue that one was, though. Right? Let's see, can we find what element is flowing where? So this is some sort of pad. Okay, here's the Syntel audio queue. Type find, and then Q2 sync. I don't think we have anything named Q2 here, right? So it's just not giving us the name of the element. But this was Syntel's audio, so it feels like this is all on the audio side that seems to be what's problematic. So now I'm curious. What if we never attached the audio? Let's just try that really quick. So on our input, or no, on our output here, when we go to link, right? Let's not link these. And let's not add the audio to the queue. So now what we effectively get is the RTMP will get the video and the audio, and our local sync will not get the audio. And we're gonna experiment a little bit and see what we can figure out, whether things start working or not. Okay, so now we have RTMP. I just saw the RTMP audio buffer was full. Did you all notice that? See? That's the RTMP audio queue. So that SVG is, we can set environment variable for GStreamer to auto-generate a SVG, well, it's really a graph.is file, from which we can generate an SVG of our entire pipeline, of the way the data is flowing through our pipeline anyway. So now it is the RTMP audio queue. RTMP audio queue. Oops, audio queue. So this is full. Yeah, it's really, really interesting, J-Hug, too. I mean, I'm still learning a lot more about GStreamer, but this makes it really, really easy to kind of visualize how data is flowing through your pipeline. So there's just some things I don't understand about the internals of GStreamer and how these streams start. That is the source of our issues right now. So like right now we have some of these elements that are like stuck in these states, but we're getting some errors about buffers being full. And so now my question here is, we've got this RTMP audio queue. So the question is this an error from this queue saying that the thing we are pushing to the queue is full? Or is this an error generated from our element saying that our own queue is full? So if we go to our RTMP audio queue, I feel like there's more information we can get here. I know that there's some, let's see, GStreamer graph is debug. I know that there's a way for us to actually print out in this SVG document this, like, what's in the buffer, like how much space they're occupying and stuff. And I don't know whether this is just they're empty or whether we don't have enough flags being passed. Let's see. Okay, so this is just debugging it there. Okay, let's do this one. Graph show verbose. Where do we put that? Is it in our mixer? Dot. All right. It's a constant. Timeout. I really need to learn more about the internals of this. All right, let's spit that out and let's see what new information we have. Wait, what did we say it was? RTMP audio queue? Okay, so that doesn't look like it gave us any additional details. Okay, so, well, this is our sync anyway, so we're expecting that to be paused. But I don't see any data here about it lied. Verbose gave us nothing. Nothing. And I'm assuming this is the same document. Oh, I guess we do have this here. I don't think the block size and stuff was here. Okay, so we removed that audio and it's still an issue. So that would tell me, we added the queue before the video too. Is it just not big enough? Is that our issue? do we do for our auto? It's in the, oops, it's in our output. Wait a second. Did we remove that? All right, I'm going crazy. I swear we just set that. Max size bytes. Okay, we're putting it back. All right, let's excuse the just random experimentation here, but we're just going to try a few things and start to try to figure out how the pipeline behaves based on what we do, and kind of reverse engineer this without digging into the C code, because I have the feeling that that's just going to confuse us more. So let's set property here, max size bytes. And this, I don't know. Let's do buffers too. I don't know what the difference between that is. I don't know whether each individual buffer is like a frame or something. Here's our audio cue. Let's do the same thing for video. All right. Oh, you have colleagues that are GStreamer maintainers? I need some of those friends in my life. Okay, so that didn't help. You need colleagues. And here I was thinking that the queue would solve all of my problems. It's always when we add RTMP. And I have the feeling that it has something to do with, let's add our audio back here. So add our audio back here, and let's try something different. Let's kill this. And let's look at our X264 encoder. And I know that there is a property here somewhere. All right. Nope. Nope. I know that there is something in here to, like, basically remove the buffer. Like, where you can basically set it as... No. No. Am I wrong? I swear that there's a property here that basically says don't buffer. It could be a different H264 encoder that I'm thinking of too. All right, I guess I'm wrong. Okay. McCann, I thought you had a job. I vaguely remember you going to meetings and stuff. Are you a one-man development team? Okay. If you call it a development team, then yes, just one of me on this team. Um. Okay, so this is some error stuff though, right? So the video mixer sent event return error caps filter test source. Wait. Which direction is this going? Because I think our caps filter is after the video mixer. Right? No, because the test source would have been beforehand. Let's go look at our... Where's our video mixer? Okay, yeah. So we have our caps filter after that, and then after that is a Q, and then a T. So video mixer caps filter Q, but that shouldn't be there, right? That's not named video test source Q, that's a different Q. Oh, it is video test source Q. Why is that called video test source Q and it's after the compositor? Alright, we need to rename that. I work for a company that does IT sales and services. I spend most of my day in Twitch chat talking up Emacs. Does it pay well? I mean, I'm a Vim person, but I'll talk up some Emacs. What was the contention issue with multiple audio streams? So that's what we're trying to figure out now. What seems to be the happening is GStreamer wants to fill all of the buffers of the elements before it sort of moves on to the next phase. So our issue is somewhere in our pipeline, we've got, say, this buffer's full, right? So it can't take any more data, but the rest of the pipeline has plenty of space, so it just sort of flows through here, and then we can't fill up their buffers because this one's full. That appears to be our issue anyway. I do need to rename this though, because that makes no sense. Where's our compositor? That's in our mixer. Compositor. Okay. Yeah, we have video test source Q. Let's just call it video mixer Q. Okay. So that's flowing this way. We've got a bunch of errors happening. And that goes in front of our auto video sync. And then this is our sync itself. Yeah, it's somewhere in here. I know we saw the other project that was using a fake sync there, but okay, I want to try something really quick. We're going to come back to this. But one thing I actually kind of want to try is what happens if we add 2 auto, because I know if we get 2 RTMPs that works. So what happens if we try to do 2 of these? I think we tried this last time. Okay. So our issue is only when we play 2, if we try to play video on 2 different types of outputs. So I do think that this has something to do with buffer sizes still. And I would have thought that this queue here would have fixed that. But it does not. So is this a caps issue? Well, normally we would get like a negotiation problem, right? If it was a caps issue. Wait, no, is it GST caps? GST caps? And I don't see any errors negotiating. That is a lot of caps messages though. Okay, what am I missing? All right, who wants to have fun? And let's just keep sticking more cues in front. Okay, we clearly have an issue here.
Yeah, it's super creative.
And now, actually, let's do this. Let's remove video. So in our RTMP output, this should verify my thought process that it's the encoder that we need lots of data for. So if we come down here and we remove all of our video, where's our link? Right, this is, yeah. Oh, we've got the mux linking to the final output, so we do need that removed. Did we comment out the video queue? We did. Okay. So this will remove the video from the output side, which in theory should unblock us. Wait. Oh, because we have to add them here anyway. It's not here. It's not here that we want to remove them. It is down in link. So that's where we add them. Here's where we link them. Okay. Oh, nope. Okay. So you all see that,
to the
right?
mind of the gatekeepers?
So if we come to our preview, we'll be able to see a few seconds of it, right? Because it was just playing. We get the sound, but no video. So that does tell me that the issue is exactly what I thought it was. Just my solution to it is not, the solution is not what I thought it was. So let's go look at our diagram here. So our issue is in fact that way down here, that this has like some sort of big buffer in it. So it never gets populated, and then we back up everything behind it because this buffer gets full and it says stop pulling more data from the stream. So basically we have all of this stuff pushing, but it wants to push out this T at the same exact time. You can't push data down one without the other. So we keep going until it gets backed up, and it's getting backed up here because this can't take in enough, is the same amount of data as this encoder does. So we either need to figure out a way how to make the buffer in here smaller, or we need to figure out how to make the buffer for the auto video queue bigger. Or the auto video sync. So how do we do that? Just inspect queue. There's a Q2 as well, and I don't really know what the difference is. Yeah, I don't know what the difference between these are. Oh, so this has like a, you know, high and low water marks and stuff. We're gonna have to look into that. Okay, let's just stick with this one for now. And I feel like we're not... I don't know what leaky means either. Maximum amount of data in the queue. So which one of these? Min number of buffers in the queue to allow reading. So we should be able to like listen for these events and be able to see that. But we did set these, right? Does 0 not work the way we thought it would? Let's back up. Okay. It was Q20. Wait, what? What are we talking about, Rocker Boo? Let's just set this to a very big number, right? Because it has a max size bytes is... Oops. And what was the other one? Max size buffers. Same thing. Okay. It's definitely on the video side though. What is this? Why does that have to be an I-32? Alright. Now, is that because it just automatically thinks it's an I-32? Are all integers I-32s? I think you can do, what, a U64 after it? Isn't that how that works? What is it? Yeah, it's an unsigned. Okay. U64. U64. Okay. Yeah. I don't know what Q that is. Because we don't have anything named that way, right? Well, let's go back. Okay. So we've got Q20 sync. Well, okay, so this is on, this is the sync pad on whatever this is. Type find element sync. All right, so multi-Q sync, multi-Q sync. Wait a second. Multi-Q queue is visible, is filled, signaling overrun. Is that in the URID code? Is that where our issue exists? Well, I don't even see it there, right? I mean, we can put a queue in front of video convert here. But the fact that when we cut video off back here, I don't think that that's our issue. And I don't even see Q2 in here. Q2, right? Okay. What is our issue? I still feel like it's an issue somewhere here. Because it's only when we add all of this to the pipeline. What happens if we remove the auto video? Because last time we removed the RTMP. So let's go to the auto one. And where's our link? And now let's remove the video from there and see if it still blocks. So it works. So it's like a conflict between the two videos. Because if we remove the video from either side, we're fine. Do we need a cue here? I don't think we do. We have a cue before the mux. Yeah, we probably should put a cue there, huh? All right. Well, we have a video cue and an audio cue, right? Where are those at? Video cue. Oh, they're just before the mux. Do we need them in front of the mux? Let's take them from there and let's put them in the front. Oh wait, that doesn't matter. We want it in the link. Let's just try this really quick. Let's move the video cue up first. I guess that part doesn't really matter. It's really that we move this here so that it's linked to our T. We might still need one in front of the mux too. Nope, still not working. I feel like we're like this freaking close. And I'm just missing something. What am I missing? I don't think adding a cue there is going to help. If we cut either video out, the pipeline flows. If we cut either video out, the pipeline works. So all of our, which is odd because our initial error is on the audio side. So does that mean that... Okay, so that means all of the audio gets populated and pushed, all of the buffers, those get full. They're blocking, right? All the way back here, we're trying to produce more video. And why is that? Oh, because we didn't update our thing. I mean, it shouldn't change much, but one of the name. Okay, so, oh, here's, maybe it did. Okay, so all of this is working. And we are like stuck in this paused state. All right, let's follow it down. Pause, 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 pause. All right, so here's our Syntel audio queue. We can see that we have data in our buffer. Okay. But all of here, we have no data in our buffers. So it is flowing through the pipeline. Okay. So these are all pass through, right? So here we've got data in our buffer. The audio mixer. So it's somewhere over here. So this queue here has data in its buffer. And that's right before the pulse. Okay, I'm really confused. Okay, so we have data in our buffer here. That comes all the way back here. Data in our buffers. There's nothing here though. So it's making its way through. So it's getting backed up here.
We have a new follower.
Thanks for the follow, Beamstream Official. Okay, so if I'm understanding the way this stuff works, our issue is sort of here, right? Because we're backing up here. And then in theory, we should see... Let's go run this again and see which buffer it says is backing up. Or maybe not. Let's kill it. Love, I can't even read what that says. Dropped something. This is some crazy wizardry. I don't have a clue about media encoding and stuff. I don't know where to start. Well, I'm happy to walk through what I do know. I am not an expert in this. I will forewarn you. I've worked in the industry before. Prior to Microsoft, I spent a couple of years at Comcast doing video stuff. So from like an abstract perspective, I understand the stuff and how encoding works and things like that, how HLS and all how things are delivered. I've not done anything this low level. This is my first time using GStreamer. So some of this is even beyond my knowledge, but we are all here and learning together. And it's actually pretty fun to learn about it, aside from when we like run into walls like we currently are. This is not Groovebox. This is base 6 color scheme. Scheme. There we go. Base 16 default dark. So we do have some sort of issue here though. I still feel like this is the issue here. Because data flows all the way through here, and then this I think is backing up. Let's just grep that. Let's do our cargo run and grep audio queue. Okay, yeah. So that is our issue. That queue is backing up. At least I'm assuming it's that queue. Can't really. It doesn't say what its name is. Q2-0. Oops. Q2. Oh. Oh. It's part of our URID code bin. So this buffer is getting full. That's why we couldn't find it before. We never regenerated this graph. So this is backing up here. But, I mean, that would make sense, though, too, right? Because if the rest of the pipeline gets backed up, right, all of these buffers are going to flow. So we should be able to just follow the backed up buffers, right? So if we follow through here, there's nothing caught in the buffers here. There is data caught in the buffers here. There's data caught in the buffer here. So these are basically in the same place because this is passed through. So these are same level, kind of. So both of those are backed up. Then we flow into our mixer. That queue's backed up. Then we go into our T. So it flows through there. So why do we have data here? And this has to do, this has to be why. Q off the T, there needs to go into a Q audio convert. Well, it seems to be the video that breaks things, right? And I think that that's because you see this Q has like almost nothing in it. I think it's because this has a very, very big buffer in it. Which would mean it needs more data, but it can't get the data it needs because either this audio or our auto video sync. Where's our auto video sync? Oh wait, did we pulled that out, didn't we? We did. So our auto video is not in here, right? Wait a second. Oh, it is in there. Hey, Melky Dev, what's going on? Everybody, huge shout out to Melky Dev. If you have not watched Melky's channel, you stream tonight, right, Melky? We're still debugging some of the same issues from last stream. Ooh, NLP interviews. Yeah, I will leave that to the smart people. Now I'm confused because didn't we just disable? Point you to the smart people. Go find the nearest mirror in your house and then look there. That's usually where they hide. Okay, so where is our auto video? Auto video. We don't even have our auto video sync in here. We broke that somewhere. What? How's it even opening though? Okay, we create our video sync. I mean, those things obviously did nothing. Okay, so we added them here. And we've linked them. I'm ridiculously confused now. Because this opens, and that is part of our auto video sync. And then if we regenerate our SVG file, and then we refresh, auto, there's our audio sync. Where's our video sync? Why is it missing? Coming off the heels of you and Dan teaching me a JS function for drop rolling where you two carried me for the majority. No, I mean, I think it depends on the question, right? If you ask me the right questions, I will look really smart. If you ask me the wrong questions, I will look really dumb. And I think that all of our experiences are that way, right? I think that's the difficulty sometimes is perception is reality, right? So we often look at the things people know and then we make assumptions about all of the other things that they must know. And so we compare our perception of what they know to what we really know. And then it's easy to kind of feel like other people are smarter than us. We all have expertise and knowledge, just, you know, sometimes it's in overlapping areas, sometimes it's in completely different areas. And like I know barely the first thing about any sort of machine learning problems and things like that. If you stuck me in a highly like data structures and algorithms interview, I'm going to bomb that thing like crazy. But, you know, you give me 8 hours a day to work on just about anything and I'm going to become an expert. Thanks for the follow, Mr. C1. Is that how you pronounce your name? Say one? Okay, so where is our issue? Run the NLP on chat. Yeah, can we add an NLP thing for the bot? Melky should come on and teach me how to do natural language processing, and we'll add it to the bot. So where is our issue? Well, two issues. One is where the hell is our auto video sync? Because it's not on here. I'm gonna let's remove our RTMP output real quick, and I'm gonna see whether that shows up on our. And there it is. So why did that not show up on our other list? All right. And who was asking the questions? It was Beamstream Official. Feel free to ask questions in the chat about any of this stuff. What's RTMP? What's a MUX? How do our encoders and decoders work? And what's a codec? And any types of questions like that you have, I'm happy to take a second, step back, walk you through our flow, what kind of each component in the pipeline does, and help you understand all of that. Because I think more people should definitely learn about video and audio and stuff like that, because then I would have more help. Okay. So this works. That pops that. So, but if we generate this SVG and we come here, is it gonna work? Wait a second. Did we not get into the pause state? Oh, we never even get into paused anymore. We're stuck in ready. We are stuck in ready. So we broke something completely different now. Because I think we were getting into the pause state before, right? Well, that explains number one issue, which is why was our thing not showing up in there. Okay, we are stuck again. We never made it. I swore we were... Hold on. Well, this has something to do with our mixer. We remove that. We really don't want... We need that to come back. So that gets rid of that change. Oh, wait. That's because we... Yeah. So let's just add this here. More verbose. Graph is output. Okay. Now what else do we change? That's just commenting out stuff. Okay. So it's really in our output that we broke something. No, that's just adding those cues. I swore. Hold on. Let's stash this. Let's do a cargo run. Okay. So that was our example here where have we been debugging the wrong graphics document this whole time? No, because we do get into the pause state here. So this is, let's back this up. So we have Sintel as our input, right? Then we have an auto output and one RTMP output. So let's pop this off the stash. Okay, so here we have Sintel with one auto and one RTMP. Okay, that's it. Wait a second. Oh. That's why. Okay. There. Now we have Sintel, auto, RTMP. The only thing we've done is add cues, right? And we're in paused. What the crap? All right. Okay. What am I missing? Because we just got stuck in that weird state, right? Well, in here I can't really see what state we made it to. That's the difficulty. But that was that audio test source queue that we saw filled up. So let's generate our graph as document. Okay, so here's our big pipeline. So it was the video test source audio queue that was filling up. Our audio test source. All right, we're just gonna follow it backwards and see whether we can figure this out. Okay, so there's nothing caught in here, nothing caught in there, nothing caught in there. This is all flowing, flowing, flowing. This is sort of expected. Why are you not playing? I don't even see any of these with full buffers. Okay, I'm confused now. Well, I can't really say I'm confused now. I think I'm in like a perpetual state of confusion at this point with this project. I just want to double check this. Let's remove this paused dot file and let's just and anything.svg. Let's clear this. I just want to make sure that that's generated. Okay. Okay, so this is so everything seems to be flowing on the video side. So it looks like it's got to be an on. Why is the T splitting into one queue and not one non-queue? Which T? Well, I mean, we have the queue in front of the sync here. You're talking about putting a queue in front of the audio convert? Yeah, I mean, we can put one here in front of that audio convert. What other T do we have? This T has... so both of those are our RTMPs. We can add them there, but I don't know if that's our issue because we did move stuff. So let's see. Those are in our RTMPs. That's auto. So I'm gonna call this video queue, and then wait, where was it to begin with? Queue. You have a queue and a video convert. It was saying to have queues on each side. Yeah, that was the one slide deck I had found. All right, let's name these. All right, so we need to bring this up here, just so we can keep. So this is gonna be our video queue, and we need an audio queue too, right? Okay, so the video queue is going into the FLV mux. So really, what that should be called is a FLV queue, right? And then we have one on the other side for the sync, okay? And then let's move you up here. Okay. And then down here, you are going to be called FLV, FLVQ. Let's call you FLVQ here. Okay. We'll do them one at a time. All right, so here we have FLVQ, and where's video queue? Here. Okay. And then when we link, video queue goes first, and then we're going to use an FLV queue here. Okay. So that will do that one. So now let's look at audio. And we added it to the type, right? Audio queue. And wait, where was the other audio queue at here? Was that before the mux? I don't even know that we need that. We'll find out. All right. I just want to organize these in a manner where they kind of occur. Shouldn't that be? Okay. And then here, that's video. That's linking our video. We'll do this in order. Okay. Audio queue. And then you need to go before convert. And I don't know. Let's give it a go. Yeah, so we're still stuck in this pause state. And we can generate our SVG here just to verify. But now we have... Wait a second. Didn't we put that in front of the video convert? Okay, so there's our audio cues. What about our video one? Why do we not have one there? Okay. Oh. because we linked it in the wrong spot. You go there. So okay. So now we have Q's there on the other side of those T's, but that still does not solve our issue. So now we look at logs. And so here, audio test source Q is full, waiting for free space. Audio, wait, what was it? Audio test source Q? Audio test source Q. So, is that just in our mixer? If we didn't add the audio test source, right? But I don't think that's an issue. I think that that's just the side effect where that starts to show up, because if that were true, when we remove the background audio and video, it should start working, but it will not. It'll probably just back up a different buffer, right? Oh, I didn't catch it in time. All right. There we go. So here, we just have the Q up in the URI decode bin that's backing up. So in this particular case, it's just a side effect. It has nothing to do with that part of the pipeline. That just happens to be the first buffer to back up. I mean, I guess in theory, if we wanted to, let's disable this, because it will make our pipeline a little easier to understand. Okay. And now let's spit that out. Okay. Which one was it? Oh, now I didn't see it. Who saw it? Okay. It is the Q2, which is inside our URI decode bin. Okay. So that is all the way back here. All the way up here. It's in here. Wait, are we not entering? So we're stuck in ready here. Where do we make it if we put that in there? I need to pay some GStreamer maintainers lots of money to teach me this. Okay, so we never even make it to paused when... Okay. Audio test source. Audio test source queue. Okay. So it's saying that this is the one that's full. But... Okay, that's the one we just ran. And we did see that message, right? Queue is full. Waiting for free space. I don't see any queue information in here, though. So the question is it here in this mixer? Or is it somewhere downstream? I mean, I guess we could not connect the audio here and we could find out. I think we already tried this though. Okay, what is this? Oh, we don't have a... Wait, we have a queue here, but where is it? Just before the mixer. Is that where we want it? Or should it be back here? But if we don't connect... Alright, let's just chop out the audio. We'll leave the test video in there and let's see if this shows up somewhere else. Okay. So... Did it back up somewhere else? Yep, it just backed up further up. Just backed up further up. So the one thing that we do know fixes it if we don't mix and match video. We don't care if there's... We can play local audio without there being a problem. And send it to RTMP. It's the second that RTMP video is mixed with local video that we start to see the issue. And we could ignore this, right? Because most of our stuff is all going to just go straight to RTMP anyway. However, I do think that debugging this is going to be extremely useful for our just knowledge and understanding of how these audio and video pipelines work. Because I do have the feeling we're going to run into issues like this. You know, we're gonna pull in a video from someplace and it's gonna cause some issue in our pipeline. And so I think debugging it is going to be important. I could be wrong. You can all tell me I'm a liar and we can try and move on to something else. But so my feeling is that it has something to do with Wait, I'm just going to remove this one more time. I just want to prove this out. So in theory, in our RTMP output, we go to our link and we do not add the RTMP video. Right. If we do not add the RTMP video, to our stream, this would play local audio and video in the little window that's popping up, and it would send audio only out over RTMP. So that works, which I think validates the entire assumption I had when I started the stream, and I'm just I'm not understanding it well enough to solve the problem. But there is something in our RTMP section of our pipeline that potentially is not getting enough data to fill all of the buffers. And that backs up the rest of our pipeline. So it's somewhere kind of in here. Data's flowing, but I don't see the backed up buffers here. And we still have our, we still have that set of rows. What is any? So what you see here on these arrows represents the potential formats or caps, right? So if we look at, say, a queue, a GSC inspect on the queue, right? We can come down here into this section. So you see how it says capabilities any? That means it doesn't really care. However, if we look at, like, say, a FLV mux, right? Here we come look at the pads. We have the source, and video X FLV is the only type of data it can take. However, on the audio side, we've got a variety of different formats that that particular pad can handle. Right? Okay. So now when we look at all of our elements here, right, we can see here that these are the formats that are supported coming in, and here's the some more supported formats coming out, and then sort of this is what the queue takes, right? So it's going to use all of this knowledge to negotiate. So everything downstream is going to make suggestions upstream, right? So this is going to say, hey, I need video XFLV. And this is going to say, well, I take anything. So that's cool, right? Same thing here. And all of these pads are going to kind of upstream queries for what formats, what capabilities there are. And then it kind of decides and negotiates which format it should use. And then whenever you see, I've got a couple of them here. You see this caps filter here, right? I guess I didn't set the properties here. Do we have one that I did set it on? Okay, so here's one you can see where I did set it on. So here, this caps filter element is kind of forcing a particular set of capabilities to be used, right? Did that make sense? So it's really just, you know, what the pads, what formats they support. Okay, so what? It is somewhere here. And now I kind of want to put like a fake sync. Here instead. Can I do that? Like, if we get rid of this, let's do it. We're just gonna experiment and. Okay, so what we want to do is we're gonna remove the X264 encoder. We're gonna remove all of this, and we don't want to connect. We don't want to connect it. So we do want the FLV mux connected. Oh no, because we don't want that connected to the, shoot. All right. we have to create two different link statements. Okay. So now what I want to do is I'm going to come up here. Oh, you know what? Let's not even do it there. Let's just create it right here because this is all debug. To remove me. Please don't leave me here to die. Okay. You know what's funny is there's actually been times in real projects I've left ridiculous comments like that in. I didn't realize they were there. Okay. You have to have a little fun with comments. Fake sync. And I know that we need to set a property on this to tell it what type of sync it is. Do we have one too many? There we go. So let's do a GST inspect fake sync. Oh, maybe not. For some reason, I thought there was something that I had to do here. All right. Okay, so we have a fake sync. Now let's just see if we can connect it here. So that's added. Let's link it after our caps filter, and let's see what happens. Now we still stay paused, even though all right, let's follow this back. So the FLV mux is just connected to the audio, and we create this fake sync here. And we cut out all of the HTTP encoder stuff. So let's back it up a little. Let's put it right after the queue. And that would mean that we could take this stuff out too.
An unauthorized connection has been detected.
Provo, what's going on? Thanks for the raid, man. How was your stream? Let's see. We're getting rid of the video convert. Is that what we were doing? Pudding Senpai, what's going on? We are still trying to debug our issues. Oh, look at this. Look at this. Okay. 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 Is it all in this stuff up here? We're getting closer. So now let's remove the fake sync and let's just pull this stuff up to here. Wait, let's back all this stuff up. The GeForce. What's going on? We're also debugging some issues. Glyph and underline positions, couldn't figure it out. Yeah, that's some of the roughest stuff for me sometimes is, you know, struggling with the whole, I understand when like I'm working on stuff and I'm not on stream. I understand I'm running into issues and things like that, and then I'll have to often go down and do a bunch of research and things like that. But I always hate doing it on stream because I feel like people probably get really, really bored with watching me struggle and just experiment until stuff works. All right, so I feel like it's somewhere in this logic that everything's breaking. I think it works. I think it works.
What brings you to the land?
All right.
of the
Well, let me
gatekeeper?
turn down the volume on here real quick.
I'm searching
Okay. So this is coming to the auto video, and let's check our RTMP stream. Uh-oh. Okay. So we're managing to make it out, but we clearly have some issues.
I've been alone for as long as I can remember.
We clearly have some issues. But it's somewhere in here. So let's just keep... Here's what we're going to do. We're going to keep adding stuff back until it works, or until it breaks. However, that does bring back one of the issues that we had before. Okay, so let's... Okay. So now we're putting in our caps filter. Which shouldn't have an issue. Okay. Let's see, Lua vim.lsp.buff.code_action. No code actions available. I wasn't looking too much at those videos yet. I need to pull those up, the ones you sent me, Rockerboo. Alright. Let's see. Video rate. Okay, so something happened there, clearly. Let's bring it back. Okay. Okay. Now let's go this direction. Video convert. Okay. So it's like the video rate one that's breaking. Interesting. Okay, so it's something to do with our video rate plugin,
Brings you to the land.
or element rather.
I'm searching.
Well, and we clearly have this issue too. And we only get this issue. We only get this issue when we're playing to both the auto.
Dangerous quest, but I know that.
Okay. But if we come into main, right? And we don't play to our auto, we only play to, let's call it 2 RTMPs. Well, no, that's not. All right. This should work fine. Yeah. I need to make sure I can clear this stream too. Now the question is this broken? Or do I just have a stale manifest file? Did we break it? Oops. No, the manifest file is still feeding stuff, so this clearly breaks some stuff. Now the question is, if we come back in here and we add video rate back in, does it fix our video in RTMP? Okay. So it's some sort of frame rate issue that we have there. So let's look at our pipeline. Do we have anything adjusting the frame rate in our, in our pipeline for our auto video? Like, do we need to add a... Okay, so on this side we have a queue and it goes directly into our sync. But on this side, we're running it through a convert, a scale, and a video rate. And we've got a caps filter here. We just haven't set anything. This is for later, because we want to be able to set the resolution and frame rate. Well, this isn't connected to a fake sync anymore, but we want to be able to set that later. So let's try adding these to our auto. Auto. There we go. We need our video convert, video rate, caps filters. We are going to add those to our auto type. Wait, why are those public? Those should not be public. Yeah, none of these should be public. Okay. Let's see. This is in the link of our auto. Yes. Oh no, this is our add many. Okay, so now we need to add them after our video queue. Convert scale rate. Oops. And caps filter. There we go. Okay. Now we need to declare them all. So here's all of our video convert scale rate, caps filter. Okay. Missing video caps filter, convert video rate. Oh, right. Because we need them here. So we've got video convert, video rate, video scale, video caps filter. Okay. 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 So this is all working. Now let's try to add back this auto here. And see what happens. Ah. And we never leave that state. Where are we going wrong? And we know we can solve this if we go into our RTMP output, right? And then we just remove... No. It was rate. We just remove rate. No, not scale. Rate. Then this works, right? But then our video is going to get all jacked up here. See?
What brings you to the land of the gatekeepers?
So now the question is, do we need to change the video rate somewhere else first? So let's see. I mean, just thinking, like, coming out of our video mixer, should that be where we're setting the rate? Right, because here we've got 60 frames a second. Why? Why is that set to 60 frames a second? Did I just do that for testing? I did. Let's make it 10 frames a second. Cargo, run. All right, because I feel like we need to. Do we have to maintain consistent frame rates for both? Is that our issue?
What brings you to the land of the gatekeepers?
And I think that's our 10 frames a second, right? Yeah.
Searching for someone.
Can we do 1 frame a second? Just for fun. Oh, this is going to take forever. In about 20 minutes, we'll actually see the movie. Okay, so our issue clearly is if we change the video rate here, we break things. And now, is that... Alright. Let's go to our RTMP output. Video rate. Is that because we never actually... We do put a caps filter there. Oh, we have to add it back. Where is it? Video rate. Alright, let's see. Does this fix our pipeline? Probably not. Oh, it does. No, it doesn't. So some... Alright. Where's our main? Where's Intel? Alright. Let's do a GST discover on this. I guess we can't see the number of frames per second in here, can we? Wait, I think there's a verbose. There we go. That's our Vorbis. There we go, 854 by 480. Frame rate. So we don't know what the frame rate is. Okay, so what do we know? We know that if we don't put the video rate there, does it happen when we remove our auto sync? If we remove the video rate, okay, so if we remove the video rate, does it still work if we don't have the other sync? Okay. So yeah. Our video rate is our stream is always broken if we don't put this video rate in here. So that is required. So that answers that question. I thought that the weird discontinuities we were getting in the video was related to the fact that we were coming through multiple sources. But it turns out that that video rate is required. Now,
I'm searching for someone.
Someone finds you interesting, sir. It appears we have a new follower.
thanks for the follow, X Tyson. Okay, so that's still timed. Let's see if we can change some of these filters real quick and just ensure that we can kind of keep these things independent. So up here in our mixer, we've got a frame rate of 30 frames per second. We could change this to 60. And then in our output, all right, so where was I going with this? Oh, right. So we have a caps filter here. Where are you? Okay. Did I removed it. All right. Let's come back here. So now let's set a different frame rate here. So coming out of the mixer, we're gonna have 60 frames per second, and then at the RTMP layer, we're gonna try and switch to 30. Okay. So let's see. Okay, so that works. That works. So we're going to leave that there. And we're also going to allow when you create everything. Oh, wait a second. This isn't auto. I'm in the wrong place. Yeah, we want it in the RTMP layer. Okay, so that was still there. Okay. So yeah, let's do this, because then on our output we can leave this. We can change what format and frame rate and things like that we want for the video to each output. So we are going to leave these elements in here. So why do these not work when we mix them? So we stick there. This is so weird to me. Okay. But if we go to link here and we just disable our frame rate, oh, wait, it's not scale. I did it again. Video rate. Okay. Ooh. Failed to link elements. Oh, we're gonna have to go through and add our extra elements to these unlinks too. So I'm confused. Right. Okay. And then it was the video rate. So this should fail because we have an element that's just dangling. Failed to link elements. Didn't we just do this earlier? why did I set that there for the key interval? I don't even remember why I set that. What? So which elements was it not liking to link?
What brings you to the land of the gatekeepers?
Alright, video convert is fine. Caps filter should be fine. Why does the caps filter not work? Is it something in our specific caps filter maybe? I wonder. We just put these here and no caps filter. Okay, so that's there. So we want video rate and our caps filter. And then I have the feeling the reason our caps filter is breaking is not linking is because we're trying to, yep. Okay, so this works. And then if we come over here, this is gonna break. The video is gonna be all crappy.
What brings you to the land of the gatekeepers?
And I'm not entirely sure why, but I do know that if we come here and we add this back, that it does work. I think that the reason our caps filter here fails to link is because if we come up to where we declare it, we're setting the frame rate, and I'll bet you if we comment this out, we don't get that error. And if we uncomment it, we get it again. Yep. So, watch. Now if we uncomment it, it'll fail to link. And the reason for that, yep, the reason for that is we're trying to apply a caps filter that sets the frame rate, but we don't have a video rate element in front of it that can convert it. Okay, so we need to figure out a couple of things. We need to figure out why this video rate plugin blocks our entire pipeline. Or, well, and we also need to figure out Nope. Okay, so when we have this video rate element in our pipeline, then our whole pipeline blocks. So maybe we need to understand a little bit more about how that element works. If we don't have that element here, then our video gets all jacked up. So we talked about in here. So the caps change everything. So every pad has caps for short, or called capabilities. So this pad is a source pad, so it generates data, has a video XRAW capability, right? And then this pad, which is a sync, so data flows to it, has its own set of capabilities. And they will try to negotiate between them what format they both use. So what we can do though is if we set a caps filter somewhere, all of this is doing is it's sort of enforcing that we use a certain set of capabilities when we communicate between these elements. But what that allows us to do, if we look at like the scale element, right, and the video rate, is if down here we have a caps filter that says, hey, I'm only going to take data that's at 30 frames per second, then this video rate element will look at that and then look at its data coming in and realize, okay, well, this isn't at 30 frames per second, and my downstream caps filter says I want it at 30 frames per second. So the video rate plugin is going to do its thing and change the frame rate. So the issue that we're getting is when we have a caps filter that says, hey, I want this 30 frames per second. And then up here is like, well, I'm going to generate at 60 frames per second. It's not going to work, right? So we could, another way to fix this, right, is, wait, where was it? Where's our, in our RTMP? Okay. So here, if we change this to 60 frames per second, it would match our mixer. And then we should be, in theory, able to remove this and have that work. Because now when it's trying to do negotiation, it recognizes that, hey, these things are the same. Does that make sense? So okay. So we do have some sort of issue. I want to yeah, so the pipeline is really, really kind of fickle in the sense that all of these things happen and all of the elements need to have their buffers full and sort of set up so that they can all start kind of moving in lockstep to the clock. So typically what happens with stuff like this is we have some sort of issue where there's a lot of buffer somewhere that's not full. And then it needs more data, but upstream is not going to produce more data because in one of the forks in our pipeline, they're blocked. There's no more room. So we can't push more data there. And if we can't push more data down that direction, then we can't push data the other. I'd imagine it to just drop every other frame if it's scaling to 30 frames per second. Okay, so let's look up the was it rescale? Is video scale. So let's look up GST inspect video scale. And what do we got? Oh no, we want video rate.
It appears we have a new follower.
Thanks for the follow, Love Snake Case. Okay, so yep, here you go. So here's where we can tell it, you know. All right. Give me 2 seconds. I'm going to use the restroom real quick. Okay. So now we have to figure out why that works. Wait, what is this? Don't produce buffers before the first one we receive. Don't produce buffers before the first one we receive. I don't know what that does. This feels like a giant red button that we should press. I want to do it. Let's press the button. We're going to press the button. Set property. Skip to first. And true. Right. Failed to link elements. Uh-oh, what did we do now? There we go. No, we still block. Okay. So why? I mean, it obviously has buffers in it, right? So removing it, is that because it needs more data? I guess I don't understand why. Why introducing that into our queue or into our pipeline would break it. GStreamer video rate. Okay, yeah, you were right. It just drops frames. By default, it will simply negotiate the same frame rate on its source and sync pad. Conversion to a specified frame rate can be forced by using filtered caps on the source pad. Okay, so here we see a URI decode bin coming in, and then we're sending that into a video convert, a video scale, video rate, and we're setting it here. That's our caps filter. So this is effectively the same exact thing we're doing, right? We have a convert going to a scale, going to a rate, and then we have a caps filter. Right? Wait. You're right. So here we're setting doing our X raw. So we are doing the same exact thing as this demo is. Let's see. Video rate. We still need to try an RTMP in as well, too. And of course, there's no documentation on using this. FF encode, FLV. Interesting. I don't remember seeing this one. I guess we would take like a multi-queue or something and send that into there. Okay. Handy elements. Yep, we know about that. We know about this. Alright, this element converts one color space to another. Yep. Yep. Okay, so same thing. Which results in different features. Unfortunately, it's often not easy to tell which queue is the best choice. Q2 performs the task listed above for Q and additionally is able to store the received data or part of it in a disk file or later retrieval. Says, as a rule of thumb, prefer Q2 over Q whenever network buffering is a concern to you. Wait a second. This element provides queues for multiple streams simultaneously and eases their management by allowing some queues to grow if no data is being received on other streams, or by allowing some queues to drop data if they are not connected to anything, instead of returning an error as a simpler queue would do. Additionally, it synchronizes the different streams, ensuring that none of them goes too far ahead of the others. Oh, interesting. But, I mean, in theory, we could use a multi-queue, I guess. Oh, can we just drop a fake sync in here? I didn't realize that. So we should in theory be able to throw them in front of an FLV mux directly. Right? So if we came here, in theory, if we found our RTMP sync element here, right? And we're gonna mark this, and we're just gonna say change to S. We're just gonna make that a fake sync. That should still work, right? No. GST fake. Oh, because it doesn't have a property on it. I think it should let you set whatever bogus properties you want, though, right? Okay, that's cool. That's good to know. That means that we can take any sync that we have and then just drop fake sync in there. Okay. So we do have some stuff here that it was recommending, right? So this said, where are you? Said Q2 performs the 2 tasks listed above. It, no. Right here. Prefer Q2 over Q whenever network buffering is a concern to you.
Someone finds you interesting, sir. It appears we have a new follower.
Thanks for the follow, Farshid. Okay, let's see. When streaming, media chunks are decoded and queued for presentation as soon as they arrive from the network. This means that if a chunk is delayed, which is not an uncommon situation at all on the internet, the presentation queue might run dry and media playback could stall. The universal solution to build a buffer, this is allow a certain number of media chunks to be queued before starting playback, and this way playback start is delayed a bit, but if chunks are late, reproduction is not impacted as there are more chunks in the queue. As it turns out, this solution is already implemented in GStreamer, but the previous tutorials have not been benefiting from it. Some elements, like the Q2 and multi-queue found inside Playbin, are capable of building this buffer and post-bus messaging regarding the buffer level, the state of the queue. Okay. An application wanting to have more network resilience then should listen to these messages and pause playback if the buffer level is not high enough. Interesting. Okay. To achieve synchronization among multiple syncs, for example, an audio and video sync, a global clock is used. This clock is selected by GStreamer among all elements which can provide one. Under circumstances, for example, an RTP source switching streams or changing the output device, this clock can be lost and a new one needs to be selected. This happens mostly when dealing with streaming, so the process is explained in this tutorial. When the clock is lost, the application receives a message on the bus to select a new one. The application just needs to set the pipeline to paused and then to playing again. So we are going to have to deal with this. Let's add that in our to-do list in our mixer. Let's see. Network resilience. Need to reset from paused to play. And we'll just add this here. Oops. We'll add that here for later. No. Don't you dare go past there. All right. So we need to change this. So this happens when we don't have a video rate element in our RTMP pipeline. If we have the RTM, if we have the video rate element, and we are also sending to auto video sync, we stall. Okay. Or stall. Okay. We also need to fix our remove output methods. They are missing our new elements. Okay. So, we're not messing with our inputs right now. I mean, I suppose here we do have these cues. I don't know. I don't know whether we put those like right in front of just our things and do we do it on the other side? Right? Like in front of our video sync here. Where is it? Where are you? Where's our FLV mux? Oh, we're in the wrong one. FLV mux. Mux. Right? Like, should this be a Q2 as well? I mean, because this is a network sync. I don't know. I don't know. Everything's broken. Nothing works anymore. It's hopeless. Okay. This is gonna drive me nuts. Right? Nope, that's not what we want. We only want it down here. It's only here. Only there. Then we go into a blank state. We work here. But our video is all jacked up here.
What brings you to the land of the gatekeepers?
I'm searching for someone.
This makes no sense. None. All right. So why when we change the video rate? Why? This is going to take one of those, like, you know, little bits of knowledge about how the individual element is implemented, I think, to understand. Why? Why? Three hours later, we still haven't solved the problem. But we have pinpointed where exactly that's happening. What is that video rate plugin name or element name? Video rate. RTMP video rate. Okay. Let's... Can we... There we go. Let's grab video rate. Okay, that's a lot more information than I was expecting. Right, we are going into pause. Where's our dot? Okay, so this is all of our craziness here. So let's back up the bus here. So now the question is there a buffer here? Like, is that the issue? This is like one wild pipeline. All right, I'm gonna back it up here just so we can kind of like really see this. It's gorgeous. I shall name you Pip. Okay. Like, do we just need more? Like, I wonder if I remove the audio, right? What if I just remove the audio and put a fake sync there? Because now this is where I start getting confused. I think the issue ends up being the reverse problem, right? We have more elements down this path. We have more buffer to fill, which means we don't have enough buffer on the audio side. But I also swore that we set like a huge buffer, and that did not work. Do we have a buffer coming out of the audio mixer? Wait a second. So the Q on this side, but we don't have one on the Syntel side. Yeah, so we're missing a Q there. And we don't have a Q on this side. I'm so confused. What did we mess up? Because we want resamples. So... Oh, we just moved our Q here on the test audio source side. I think this was one of our experimentations. Do we have a change to that? No, we don't. So, where's our Q? Because our audio Q should really be... No, it's in the mixer. Our, what's it called? Audio test source Q. Test source Q. Okay. So you should really exist on the other side. You should really exist before the mixer. That's not going to fix our issue, but okay. So there's our conversions and our resampling, and then a Q, and then they go into the mixer. Do we have a Q on the other side of the mixer? We don't. We have a caps filter and then a T. But we have Qs everywhere on the other side. I don't know that putting a Q here is going to help. There we go. Pettermaster's got it. I'm really surprised. I've been on stream for like 3 hours and the colors have changed in here like once. Well, twice. I changed them once. I'm going to add a Q here. I don't know that it's going to help, but we do have one on the video side coming out. So let's do that. I'm not hopeful, but at this point I will try anything. All right, so here's our video mixer queue. Where's our audio? All right, oops. Audio. If it's not too much trouble, could you share what the pipeline currently looks like as if you were to run it on the command line? Oh, you want me to kind of pull up a you want me to translate this into like a GST launch command? It would probably be pretty complex to do that way. We do have a diagram here kind of showing how these things are going into each other. And this is like sort of cutting it down a little bit. But yeah, I mean, the gist of it would be like a URI decode bin, pipe, you know, URL equals foo, piped into a like a video, yeah, URI decode bin would go into a, basically like a video convert piped into a compositor, piped into an FLV or X264 encoder, piped into an FLV mux, piped into an RTMP sync, except this gets a little crazier because that's only the video side of it. Then there's also the audio side of it. And then we also tee that all out and then send it to multiple RTMP syncs and stuff like that. And then also embedded in here is a video test source and audio test source. And the reason for that is so that we can maintain data flow through the pipeline at all times. But here, let's, I can do it this way. Let's come to our input here, or our main. And what I'll do is I'll cut out all of the craziness of like multiple RTMP streams, and we'll take RTMP off the other side. And so what we'll do is we'll just have this URI decode bin, and we'll send it to a single auto video sync and auto audio sync. And then I can run this and you can kind of get a feel for the gist of what the internals of it are. Okay. So let's generate our dot file of playing. All right. Okay. Okay. So this big box here is our URI decode bin. And that ends up connecting here, where we're just running it through an audio and video convert, resample and putting some cues there, right? And then we also have an audio test source, which is generating a sine wave, and we've set the volume to 0. And all of that's getting mixed together here in the mixer. So that's going to ensure that there's always data flowing here, even if we swap out the input. Okay. So now we're just setting a caps filter. And then we have this T, which we can add multiple, and this is so that we can, coming out of the mixer, we can have multiple outputs, because we may want to send this to multiple places, to RTMP endpoints, maybe to video, right? RTP, we can come up with a bunch of things. And then that flows out into our audio sync. And then we have the same thing on the video side, where we're combining a video test source, which right now is just a black background playing. And this is always playing so that we can disconnect this input whenever we want. And same thing, that flows into a compositor. We've got Z order, so our black screen is always on the bottom and our video is sitting on top. And that's just flowing through a caps filter to kind of enforce the output resolution and things. Same thing, we send that out to a T so that we can send it to multiple places. So this is kind of like a trimmed down version of it. Obviously this gets a little crazier like with this one, and that's because we have our multiple inputs, except it gets really wild when we come over here to our T's, right? So here's our video coming out, being split, and this is going to the auto video sync, but also we have two encoders, which are coming into two separate FLV muxes, which are putting the audio and video back together and sending them out. Does that make sense? I still don't understand why that scale or that video rate messes with us. Wait, what is this? Why are you not connected to anything? Backup FLV. And RTMP FLV. Wait a second. We've got some dangling elements here. Underscore FLV. FLVQ. Okay. Here's where we add it. Did we not? Ah. Okay. Okay, so now we don't have those dangling cues there, but it still doesn't fix our issue. I don't understand. There's a part of me that wants to try and cut out the audio and see whether that fixes our issue. But I think it's obvious that there's something about that particular element that causes our issue. Let's do that. Let's go into the mixer. And where's our T? So let's go to our auto output, and then this is the wrong one. So we want link. All right, so this is our auto output. Let's cut out our audio. Okay. And then let's not link those. Okay. So now our auto, and it only happens if we mix the two, right? Is that true? I think that's true, right? Yeah, because I think we've tried so many things here that I end up like forgetting what we've tried not. Okay, so I think this works. Yes. Okay. So our issue is not the introduction of that element. It's only that element when we are also sending to the auto syncs. Or at least I thought, because I don't see video coming through here. What am I missing? You're lying. Oh, we're only sending to the one. So it should still be this one. Okay, now we should be going to both. Okay. So this works. So it's not a multi-stream issue. It's not the fact that the element exists at all. It's only when we mix our output types. Let's cut out the video on the auto side. All right. Okay.
What brings you to the land of the gatekeepers?
I'm searching for someone.
Thanks for the follow, Gooby Goober. All right. Why is this not playing though?
Dangerous quest for unknown hunter.
What am I missing here?
I've been alone for as long as I can remember.
Okay. So you say you're playing, but you are not. I didn't comment anything out, right? No, I didn't.
What brings you to the land?
Did I create some new weird bug? Because it's playing, but it's clearly not making it there.
What brings you to
Wait,
the land
what?
of the gatekeepers?
Did you all just catch that?
I'm searching for someone.
So it works when both RTMP endpoints are there, but not when there's just one. It says it's playing, but then data never ends up there. Like, this is still the old manifest file.
I'm searching.
But if we kill that, and then we play it to 2 RTMP endpoints, you'll see this grow to past 19 seconds now. Oh, wait a second. This one's the backup. That one's the regular.
What brings you to the land of the gatekeepers?
Maybe I'm wrong. Maybe I'm just dumb and I just was refreshing the wrong screen. Let's try this again. Okay, so we've got 38 seconds on the clock here. No, I was right. This one's... Oh, they're the same freaking URL.
What brings you to the land of the gatekeepers?
I'm searching for someone.
Okay. I was right. I am dumb.
A dangerous quest.
Okay. So it works as long as both video syncs are not there. So what does that tell us? Does it tell us anything? So if we take out our video rate, or we take out the auto video sync, I mean, the only difference between these two pipelines is that in our RTMP one, we do have some queues on the sync though too, right? So like if we did like a video sync queue, I don't know. We need to update our naming conventions here, but I'm just gonna, I want to try this real quick. Let's put a queue here before the video sync.
Appears we have a new follower.
Thanks for the follow, Matthews02. What's going on? I'm curious what time zone everybody's in here. I know it's always like the end of my day, but I wonder like what time zone everybody else is in. Missing video sync queue. Okay. So that's there, and now we need to go to our link. All right. Pacific? Oh, well, I know where you are, Aaron. It took me a second to realize who said that. Mateus, me too. I'm Eastern as well. So this is always the end of my day. I finish up my day with a stream. All right, we're going to add a queue here. I don't know whether it's going to work or not, but it does seem like a difference we have between these. Did that... Wait a sec. Wait a second. Wait a second. Did that seriously just fix it?
What brings you to the land of the gatekeepers?
3.5 hours. 3.5 hours.
I'm searching for someone.
3.5 hours, and all we had to do was add a freaking queue before the sync. But hey, let's do this. Let's see if it goes to both. Let's make sure we refresh here. Skip to the end.
What brings you to the land
Okay.
of the gatekeepers?
And let's refresh here.
I'm searching for someone.
So apparently the answer to all of our GStreamer issues are we just keep adding queues everywhere until it works. Yeah, it is. It is like a forgotten comma. It's a forgotten queue. I still don't 100% understand why we were getting hung up there. And I would love to talk to somebody who knows GStreamer better for me to be able to better figure that out. I have a rough idea conceptually why these things are that way, but all right. So what do we have here? Okay. All right. I think this is all good. I don't think we really have any debug code here. Okay. What else we got? We changed the mixer? Oh, yeah, change the frame rate there. Oh, okay. Here we go. You ready? Git add source. I mean, sure, we can commit it this way. We're gonna remove that there. Okay. Git commit. You ready for this? Rockerboo, you called it. This is our commit message. Am I missing a quote somewhere? Wait. What? How did that happen? There we go. All right, I'm so confused. There we go. All right. We're going to push that. And now, the other thing that we needed to do is, I do know that, wait, what are you complaining about? Oh, expect failed to remove output. All right. Okay. So we've got a lot of like warnings and stuff to fix too. Wait, what is this? Unused variable audio cue in the mixer? What? Did we create it and then not use it? Audio cue. What line is that on? 97. Apparently we didn't need it. Alright. We'll get rid of it for now. I'm sure we'll put it back later. Field is never read. Name string on line 57. 57. Oh, that's fine. Remove input. That's fine for now too. Okay. So, in our outputs, we have our unlink, right? Unlink. It should have all of the add many. Unlink. Remove many. There we go. We'll grab the audio ones too. Add many. Because we need to make sure we don't have any like dangling things here. Okay. Let's also go up to the auto one and make sure we do the same thing. Because we added some additional elements there. That's our RTMP one. All right, here is our link. Add many. Boom. Okay. Unlink. There we go. Cargo build. Cargo run. Cargo run. Alright. So that's still playing even after we've removed the backup. So that tells us we have no dangling elements. Perfect. Update. Oh, wait. Where's our mixer? We can remove this here. We can also remove that one. Okay. So, cargo. That was just git commit. Update remove output to include or to update unlink output unlinks to include newly added elements. Okay. All right. Does anybody have any questions about all this stuff? I'm going to call it here. There's no point starting anything new, but I'm happy to hang out for a couple minutes in chat, answer any questions. Anybody who is new here, I'm happy to walk through what exactly it is that we are building or give you a 5 or 10 minute video and audio streaming and multiplexing 101 lesson. Try the code actions. Okay. The other thing is too, so with this working now, we have multiple inputs, multiple outputs. We can stack everything. We've kind of proved all of this. So the plan for tomorrow from 1 p.m. to roughly nowish, 4:35 p.m. Eastern time, is we will be taking a look at, is it warp.rs? Nope. Warp Rust. There we go. We will be taking a look at this warp project, which allows us to set up an HTTP server and do some stuff. And I imagine that's what we'll spend all day doing, because now what we want to do is we want to create a HTTP API for us to be able to add and remove inputs and outputs programmatically. And so that's what we're going to work on. And I highly, highly suspect that we are going to get some issues where our pipeline breaks. We tried to think about a couple of them ahead of time, which is why there's like the test audio and test video source with data just constantly flowing. However, I think we are going to have some issues where if we connect or disconnect things at just the right time, we'll get a race condition that may cause it to break. And that's why we have sort of like this info here, that what we really want to do is, set an idle pad probe and then use that to unlink it. And I don't know whether we're going to have an issue here or here, right? When we try to add something in the middle. I think we've already figured this stuff out, but yeah. So that can probably come out of there too, but we'll leave that for now. So that is the plan for tomorrow. Lots of Rust and HTTP. I've never used that library. We're going to see what happens. And we're going to, after I don't even know how many days fighting why our pipeline breaks, we're going to try and break it some more because that's what we do. All right. What do you got for me, Rocker Boo? All right. All right. Assist code actions. Assist or code actions are small local refactorings available in a particular context. They're usually triggered by a shortcut by clicking a light bulb in the icon on the editor. Cursor positions are... Adds implementation block for derived trait. Before... Okay, so let's go into, I guess in our inputs, right, we have derives, right? Is it in our mixer? There we go. Is that it? Nice. All right, so what was the other option? Oh no, that's the one I already did. Oh, this is cool. This is cool. So is that what you all implemented last night? Oh, it's standard already. All right. Does anybody have a config already for that? Well, I guess it doesn't really matter, does it? It's just that one command. So I just need to like, I don't know. Where do I want to put this in my config? Where do I want to put this? Where do I want to put this? It's not a Rust thing. Completion? Completion. Hey, Boolean. Let me just copy this thing from Rocker Boo. Okay. I'm gonna have to remember to set that up. Okay, so Boolean, we are building an RTMP switcher. Well, I'm about to call it a day today, but tomorrow we're gonna pick back up on the HTTP server side of things. So let's take a look. This is what we're building. We're building this switcher component here, and the idea is that we want to be able to have multiple people, and I can pull this up here. This is our original diagram. So we want to be able to have multiple streamers take OBS and push to some RTMP endpoint. We're going to spin these things up programmatically, and it's just going to sit here and nothing's going to happen. our switcher is going to be configured to go out and pull data from that RTMP feed and then push it out somewhere else. And so we're basically making multiple in, multiple out. So we could send this streamer to multiple places. We could send this stream, route this streamer this way, this streamer that way. We could swap these out on the fly and add new ones. We could also record to video. We could record the out, or we could record an individual streamer. And what we'll be able to do is now say Twitch is getting streamer 1. Well, then we switch over to streamer 2 and we could swap back and forth like camera angles almost, so that you could say have an MC introduce a speaker and then switch over to them. And so we're creating this like production video switcher in the cloud with video streams. And then to kind of take that up another notch, we're also going to be able to pull videos and play those out. So it can be any combination of these things. And then a coworker of mine is building this scheduler piece. The Gash, thanks for the follow. So a coworker of mine's building this scheduler piece, which will allow us to automate what the switcher does. So it's at 1 p.m., streamer 1 goes on. At 2 p.m., we automatically switch to streamer 2. At 3 p.m., we don't have a live person, but we're going to play a video from a playlist. And we're just going to keep that thing going. And then that's sort of the MVP. Then from there, what we're going to do is the scheduler may know, hey, we actually have a pre-recorded video of streamer 1's talk. If their bitrate drops below this amount, we want to just go retrieve the video from their pre-recorded session, seek to roughly the point in the video that they would be in their stream, and continue playing from there. We can also do some things like picture-in-picture, where if we want to put streamer 1 down here in the corner while streamer 2 is going, we could do that. It'd be cool to be able to do transitions and do like lower thirds down here, where we already have the streamer's name and things like that. That's already held in the calendar here in the scheduler. We could display that stuff on screen. Yes, so RTMP is real-time messaging protocol. I always want to say media. And it actually came out of the Flash video player. So it is just used to transport the streams. So if you have ever streamed live to YouTube, Facebook, Twitch, anything like that, you have used RTMP. So inside of an RTMP feed, that's where we switch to our other diagram here. Or not. Oh, did we lose that whole drawing here? Oh, we lost our drawing. Apparently you can only have one drawing on Excalidraw. Well, that is sad. I don't think we saved it, did we? Did I save it? Was I smart enough to save it? Probably not. I'm not a very smart man. No, I don't see it in here. That's where I would have saved it. Yep. We lost it. That was a cool drawing. But anyway, so inside of an RTMP stream, you have a container format. And so if you think of MP4, AVI, MKV, that's a container format. So a container format is just how we package up and move around multiple streams. So that could be multiple video, multiple audio, closed captioning, all of those things combined together. We call that multiplexing or a mux. So you mux these things together and you stick them into a container, which could be on disk, or you could transport that container over HTTP or RTMP. Okay, you with me so far? So each of those streams, say audio and video, are encoded with a codec. And that's how we compress them and we make them smaller. They take up less space on disk and require less smaller internet connections. So, and your individual container format will support different types of codecs. So not every container will support every codec. So for example, FLV built into, especially RTMP, there's only a set number of bits that can be used to represent what the encoding type is. So they have them actually hard coded. So typically you will see either MP3 or AAC audio sent, and you will more than likely see H.264 encoded video. So that's how all of that stuff works. Now, if you want to kind of know how all this works, what happens is RTMP is pushed over here, and then they typically have a transcoder or a transmuxer. So that video is then taken and it's scaled into multiple resolutions.
Someone find you interesting, sir. It appears we have a new
Thanks for the follow, Cyberabora. So on this side, when the RTMP feed comes in, they take that FLV mux, they demultiplex out the individual streams, and they may re-encode the audio and video into different formats, as well as scale it to multiple resolutions. Those are then stored on disk. We call it packaging. And then distributed out over a CDN. So then the player is actually going over HTTP, and Twitch is HLS, but MPEG- is another one. They go out over HTTP, they retrieve a manifest file that is just a list of all of these 2 to 6 second clips of the video. When it went through the transcoder, it's usually split up in 2 to 8 second chunks. So you're getting a manifest file, and we could do it right now, right? Where's my stream? Let's see if we get an echo here. Let's see, eric.dev. I think my video is muted. Okay, mute. All right, there we go. So we could open up here, and we can go to the network here, and we can search for M3U8. That is the extension for where are you? It should be playing. Oh, because I'm here. See? I don't have all. There we go. Now here is an M3U8 file. And we're going to save it. Okay. So, now if we switch over here, we can go open up my downloads folder here. Downloads. And we can find our CV crazy M3U8 file. This is what's generated on the Twitch side. And now what we can see here is URLs for these individual segments. And it looks like it's delivering me them out of Miami. And so their server is probably smart and uses some sort of GeoIP thing so that this manifest is generated with URLs that are based on a CDN close to me. But you see this TS file here, that is a transport stream. These are usually MPEG files, and it's going to be, 2 or 6 seconds, right? Okay. And that's all we're looking at here. You can actually see it here. 4705, 4707, 4709. So we are actually looking at 2-second segments. Now, these manifest files can also maintain multiple different versions of these, and that can be like per resolution. So what will happen is while you're watching, either you select the different resolution and then the player starts looking for those, or you get buffer underruns in the player where the player's not able to download the data as fast as it's playing it, and it'll go back to the manifest file and it will just look for a lower resolution and then start fetching you segments that are the lower resolution. And that's exactly how adaptive bitrate works, and why if you're ever watching Hulu or Netflix or YouTube or Twitch and the video just kind of gets more blurry for, some multiple of 2 seconds typically, and then comes back, that's exactly what happened. You had a little glitch in your network. The buffer wasn't able to be filled. It went out, fetched just lower resolution for that 1 segment, and continued on. Yep. So, that's all they're doing. They're taking in your feed, doing that. There's obviously some magic in all of the compression and re-encoding and things like that, right? Because the video stream coming in may not always be the same as is going to be going out. But yeah, that's the gist of it. And that is video streaming 101. But yeah, it's extremely interesting to learn about all of this stuff. Okay. I am going to get something to eat. I have not eaten all day. But tomorrow I will be back on at 1 p.m. Eastern time, and we'll go for about 4 hours, and we're going to start working on the HTTP server where we can start sending commands to change up our stream on the fly. So HLS is supported more on Apple devices. That's actually who invented this standard. Whereas, and there's like embedded HLS players, like native players in a lot of mobile devices. So typically you'll see people who are targeting mobile devices using HLS. MPEG- is another standard. It's actually done in XML. You will see that used typically by a lot of cable companies and stuff like that.
We have a new follower.
Thanks for the follow, Boolean. They're both used equally, so it's hard. There's also Smooth too, right, which Microsoft created. So yeah, it just depends on who's using it and what devices they're trying to target, but they're all kind of evolving toward the same place. HLS is probably the one you will see used the most. We got Prime doing LSP stuff still. Trying to find somebody new. Who haven't we rated? Oh, wait a second. Where's Aaron? Isn't Aaron supposed to be streaming? Oh, Aaron is streaming. Let's go raid Aaron. Aaron was just in here hanging out. Aaron should be working on some Kubernetes and Docker stuff. Thank you everybody for hanging out. This is a lot of fun. I love getting to hang out and chat with everybody and fail miserably publicly in front of all of you. Thank you for not ridiculing me for that. Again, I'll be back tomorrow. Thanks, Notorious.